Okay, this is Mr. Peterson, and we're picking up where we left off for the Math 31 Notes sections 7.1 and 7.2. This is the second of two videos. Okay, we've learned a couple other types of graphs, and now we're going to turn our attention to a histogram. A histogram is actually a bar chart or a bar graph, and the difference is that the height of the bar represents the frequency of certain data values within a range that you preset. So you're going to be counting the numbers that are in a certain range. Now I'm using an example here that should be a little familiar to you. We're looking at a class, a chemistry class, Professor Plum's chemistry class, and these are his grades for a given exam. There were 35 students, and the exam grades are listed in order from lowest to highest here to make it easier. Okay, so you're going to just count the number in each category. To start with, in the first interval, we have two students that scored in the 40s. So they did very poorly, and we tally them and then write the frequency. There was only one student who got in the 50s. So we tally it and then write the frequency. And then we have 5 students who got in the 60s. And then in the 70s, we had 1, 2, 3, 4, 5, 6, 7, 8. Frequency of 8. The next one, we have 1, 2, 3, 4, 5, 6, 7, 8. 9, apparently. Hold on. Oh, no, there's 10 there. I forgot those two up there. So there's 10. In that interval, 80% to 89%. And then in the remaining one, there's, I think, 9 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9. Okay, once you have that, then you make a bar chart using the frequency numbers, and that is precisely what a histogram is. So you can see that, for instance, in the 70 to 79 range, I should have a height of 8 here, and I do. And then the highest, the most common category here were students who scored in the 80s, and there were 10 of those, and you can see this bar reaches up to the level of 10 here. Okay, so that's how a histogram works and how you make one. Now we're going to use the histogram to answer some questions. Okay, would the histogram's appearance have changed if his grading scale changed? And the answer is yes. For instance, if you made a more generous interval, instead of 90 to 100 being an A, if you said 85 to 100 is an A, then there would have been more than 9 students scoring or getting that grade. So we're going to uncover the answer here. And I'll give you a minute to write that down. Now, while you're doing that, I want to point something out about these intervals that is very important. The intervals should, if at all possible, be exactly the same width. So if you look here at the first interval, 40 to 49, that's 10 percentage points, and then the next one's also 10 percentage points from 50 to 59, and 60 to 69, that's 10 percentage points, and it's going up by 10 at each time here, and that keeps those intervals the same width. That is considered to be required for these histograms. So why were the failing students split into 2 groups on the histogram? Well, that would be the reason is that we have to keep these intervals the same. So I can't just lump the people that got 50s with the people that got 40s because I have to keep my intervals at 10 apiece. So even though we don't normally distinguish between an F and an F plus, in this case we do, we don't lump these together because that would make an interval that's 20 wide, 20 percentage wide instead of 10. Okay, so I'm going to show you how to word that answer here. The class intervals should be equal in width. Okay, the next type of graph we're going to look at are called line graphs. And these line graphs are wonderful when you want to show a progression through time. So if you look at this first example here, we've got the average monthly temperature in Santiago, Chile, measured in Fahrenheit. Now, we measure it in Fahrenheit. They wouldn't. They would do centigrade. But this is obviously for the consumption of an American audience. And there's two separate colors shown on this graph. The blue color represents the high average. In other words, when the temperature is warmer, presumably in the middle of the afternoon, and the low temperature for that given month. Okay, now these are average temperatures. That's what it says here, average. So for instance, this first dot on the red line here tells us that the average temperature for the month of January, a low temperature for the month of January in Santiago, Chile, is about 53 or 52 degrees Fahrenheit. Okay, so with this chart, and one of the things I want to stress on these graphs, you have to read everything so that you can interpret. Those legends around the outside are really important. For instance, in the first chart we had on the other video, the size of Europe was listed as 3.9. But you had to read the legend to find out that that was 3.9 million, and then you even had to put more information, 3.9 million square miles. Okay, so what's the average high temperature? We're going to be looking at the blue line. For the month of November, we're going to be looking at the blue line in this column. In other words, we want to know that dot right there. Okay, so this dot here lines up with 80 Fahrenheit. So it's actually quite hot or warm in November in Santiago, Chile. Okay, so what's the average low temperature in July? So we find July and we put ourselves on the red line because that's the low temperature line. And then we read the scale over here, and I would probably say around 36 degrees Fahrenheit. So you probably pull out your jacket or a strong sweater or something at that point. So why would the temperatures in June and August, or June through August, in other words, this section, why are they the lowest temperatures? We're used to June, July, and August as being really warm months of the year. And the answer here is pretty simple. It's the southern hemisphere, so the seasons are reversed. I grew up in Brazil, and in Sao Paulo it gets cold in June and July instead of warm. So you want to go to the beach in January. That's when you really want to go to the beach in South America. So why are the low temperatures in Santiago so moderate? Well, the chart doesn't tell us this. We'd have to look up other information and have some knowledge about geography and so forth. But it is an interesting question. Why is it so moderate? I mean, if you think about, just say the Midwest. I live in Kansas City area. Our temperatures are much more extreme. We go up into the 90s and all the way down into the 20s or below during the winter. And there's not a lot of fluctuation in Santiago, Chile. And this is, wait for it, it's the ocean currents. Chile has a warm Pacific Ocean current that comes all the way down the west coast of South America, and it moderates those temperatures, makes it really good for growing fruit. A lot of fruit is imported from Chile to the United States and other places in North America. during what is our winter months, December through February. Okay, the last type of graph we're going to cover is a circle graph, or sometimes called a pie chart. And this graph is really good for showing a portion of a whole. In other words, where are you putting the most resources, for instance. The percentage in a pie chart should always add to 100%. So here we go. We have 12 slices of blackberry pie in my fridge, and I only got one slice. 1 out of 12, 1/12 is 0.08 or close to that, so I got about 8%. I ate about 8% of that blackberry pie. My wife had 2 slices, and 2 divided by 12 is a little less than 17%. I'm rounding here. And my son, he ate 4 slices. If you take 4/12, you get 0.33, repeating actually. So around 33% of the pie was consumed by my son. At least we think so, because if you look down the road a little bit here, there's 2 slices that are unaccounted for, and I'm not really sure who ate those slices. I just know it wasn't me. So who's been hogging the most pie? Well, if you believe the numbers here, it's my son. Okay, and who got the least pie? Oh man, you need to feel sorry for me here. And you can tell just by seeing the thickness of the chart slices. Okay, you got a real thin slice there, which indicates that I didn't get very many slices. From the chart, what percent of pie was eaten by my offspring? Well, my girl had 25%, and my son had 33%, at least very close to that. We're approximating a little bit here, which is 58% of the pie was eaten by children of mine. Oh my gosh. Yeah, why you shouldn't have children. Okay, how many degrees out of 360 possible are dedicated to my girl and myself? Okay, so you're going to take 25%, that's my daughter's percentage there, times 12, and that would be, I'm sorry, 12 would be the number of slices. A circle has 360 degrees in it, so 360 degrees, and that would mean that little sliver here is a 90-degree sliver. And then the calculations for mine would look like 0.08 times 360 degrees in a whole circle. And that turns out to be approximately 29 degrees. And so together here it's 119 degrees. 119 degrees is the number of actual rotation degrees that are dedicated to those 2 slices. Okay, the last one we have here in this section, section 7.2, is a chart that I pulled off the internet, and don't blame me for it. I don't think it's done very well, but at any rate, it's the population of metropolitan Toronto, Canada in the year 2016. It tells us that in the information up above here. And we have percentages given. So how many Chinese lived in Toronto during this census or time period here? Well, it does tell us 10.8% over there in the Chinese slice. So let's put 10.8%, that's what that is right there, times the base value of 6,400,000. And that tells us that there were 691,200 Chinese living in the city of Toronto at that point. Okay, how many non-visible minorities were there in the city? I have no idea what non-visible minorities means. I suppose that means you can't tell by looking at them if they're a minority or not. So this would be, I don't know, not really sure. But 48.6%, and you multiply that by the base value of 6,400,000 in the city altogether, and that turns out to be 3,110,400 people, or non-visible minorities. I'm not sure if that's a minority that's invisible or not, but can't really tell. Okay, so what percentage of the should the chart sum to here? Well, if we add all those percentages up, so let me just show you the ones I'm adding. 16.6, 10.8, 7.5, 4.3, 12.1, and 48.6. If you take the trouble to add it all up, it turns out to be 99.9%. And this is problematic. The chart should add up to 100%. So the chart has issues. Now, being off by 0.1% is not a real big deal. So you'd be quibbling over something very minor if you said, oh, that chart's wrong. It just really doesn't matter that much when you're off by this little amount. Okay, so that does it for those notes, and I hope it's enough that you can now do your homework. I probably won't be putting out homework videos here since these notes are so similar.